November 11, 2025 morning. After vanishing behind the sun for 6 full weeks, the eagerly anticipated 3i Atlas has finally returned. And when it came back, it brought an unexpected surprise. A real tale. The latest images released from the Virtual Telescope Project's Manciano Observatory in Italy are proving what has been full of questions all along. 3i Atlas has a magnificent ion tail. And this tail is growing longer every day, remember? In October, astronomers were discussing a puzzle. Where is 3i Atlas's tail? According to NASA's calculations, it should have lost 10 to 20% of its mass during perihelion passage near the Sun. Some estimates push this to 50–70%. Such massive mass loss should create a giant debris tail hundreds of thousands of kilometers long. But the tail wasn't there. Or so it seemed. On November 10th, the Virtual Telescope Project captured the ion tail clearly in images combining 14 exposures of 120 seconds each. Follow-up images released on November 11th are even more striking. The tail is growing longer and brighter. The project director wrote in a note accompanying the images. Now the tail is visible from Earth because 3i Atlas is moving toward the morning sky. And the tail that was behind the nucleus from Earth's viewing angle at perihelion is now becoming better visible with each passing day. Here's the explanation. The tail never disappeared. We were just looking at it from the wrong angle. Like looking directly at a car's headlights. You see the light source, but because the light beams are coming straight at you, you can't see what's behind them. 3i Atlas's tail was pointing away from the sun, away from us. We were looking at it almost from above, along the length of the tail. Now as its orbit changes, we're starting to see it from a side angle, and the view is magnificent. On November 9th, German astronomers Frank Niebling and Michael Buchner captured perhaps one of the most detailed photographs of 3i Atlas. The composite image they created by combining 5 images with 2 different telescopes, TEC 140 f5 and ASI 6200 mm, with 5-minute exposure time reveals an astonishing structure, 2 anti-tail jets extending 10 arc minutes toward the sun. At 3i Atlas's current distance, 326 million kilometers from Earth, this angular size corresponds to a spatial magnitude of 0.95 million kilometers. One main jet, a much longer collimated jet extending away from the sun, 30 arc minutes long, as large as the moon's or sun's apparent diameter in the sky, calculated spatially, 2.85 million kilometers long. Harvard astrophysicist Avi Loeb detailed these numbers in his analysis published this morning and reached a tremendous conclusion. The mass density at the jet's outermost part gives a mass flux of 2 million kilograms per second per million square kilometers, he wrote. Summing over an area of about 10 million square kilometers yields a mass loss of 50 billion tons per month. Digest that number for a moment. 50 billion tons per month. Loeb continues. This mass is comparable to the minimum mass of 3i Atlas, 33 billion tons, which I calculated from the lack of non-gravitational acceleration in the months preceding October 2025. Assuming a solid density of 0.5 grams per cubic centimeter, the diameter of 3i Atlas must be larger than 5 kilometers. If it's a natural comet and most of its nucleus survived perihelion intact, its diameter should be 10 kilometers or larger. For comparison, this is at least 1 million times more than Oumuamua's estimated mass. Last week, some media outlets ran headlines saying 3i Atlas has no tail. Dr. Ken Gailey, an astronomy professor from the University of Iowa, told Live Now from Fox. We always start off with the assumption that these are natural objects, and we study them in that way. Gailey was right. The scientific method starts with natural explanations by default. However, the tailless claims were based on an early observation period. The truth is the tail was there. Our viewing angle just prevented us from seeing it. Now, as the angle changes, the tail becomes more prominent every day. The Virtual Telescope Project team noted in their latest images from November 11th The ion tail is getting longer, despite the presence of a bright moon at 71% full phase. Telescopes clearly detected 3I Atlas's ion tail. This proves two things. Point 3I Atlas really did lose a large amount of mass at perihelion. The calculations were correct. The object is exhibiting characteristic behavior of a natural comet. Solar radiation ionizes gases, the solar wind sweeps them away, and a classic ion tail forms. However, this doesn't explain all the anomalies. On November 2nd, Crimea-based amateur astronomer Gennady Borisov, the same person who discovered the second interstellar object 2I Borisov in 2019, discovered another comet, C-2025 V1 Borisov. This new comet is reaching its closest point to Earth today, November 11th, 103 million kilometers, about 270 times farther than the Moon. Initial reports tried to link C-2025 V1 with 3I Atlas. Some internet theories went further, suggesting it could be a probe launched by the 3I Atlas mothership. Avi Loeb quickly dismissed these claims. C-2025 V1 is not related to 3I Atlas if it did not employ non-gravitational propulsion, he wrote. The distance between the two objects at their minimum separation was about 25 million kilometers, likely too great to explain an association between them. So, why is it called nearly interstellar? C-2025 V1's orbit is extremely eccentric, meaning it's approaching the Sun on a very straight trajectory. According to Avi Loeb, this orbit is very close to hyperbolic, meaning very close to escaping the solar system, but not quite. If it's moving fast enough, it might never return. This resembles 3I Atlas's definite hyperbolic orbit, but not as extreme. Still, C-2025 V1 has no connection to 3I Atlas, just a timing coincidence. However, the same astronomer discovering two unusual comets, one truly interstellar, one nearly interstellar, is noteworthy. After Reppers Anna Paulina Luna's official letter to NASA, a meeting was held last Wednesday. According to Defense Scoop's report, NASA officials met with Luna and her team about 3I Atlas, an anonymous government source confirmed. NASA officials are tracking the interstellar comet and intend to release relevant findings, data, and observations once the U.S. government reopens. The Pentagon's All-Domain Anomaly Resolution Office, ARO, the UAP, Unidentified Anomalous Phenomena, Investigation Unit, confirmed it is monitoring 3I Atlas. However, a Pentagon official stated the object is not considered a national security threat. Avi Loeb criticized NASA for lack of transparency on the Joe Rogan Experience podcast. This situation reflects terrestrial stupidity rather than extraterrestrial intelligence, he said. Loeb specifically emphasized that the clearest images of 3I Atlas taken by ESA's ExoMars, Trace Gas Orbiter, and Mars Express during its October 3rd flyby at 30 million kilometers from Mars have not yet been publicly released. ESA has been more transparent and released these images. NASA's Psyche spacecraft passed close to 3I Atlas on September 4th, but no images from that flyby have been publicly released. The lack of data creates speculation, and Luna's congressional intervention increases pressure for public disclosure. These days from now, on December 19, 2025, 3I Atlas will reach its closest point to Earth, 168 million miles, 270 million kilometers. This distance is about 100 times larger than the spatial length of today's jet. Structure, 285 million kilometers. This means Earth-based satellites won't be able to capture particle samples from these jets. Similarly, NASA's Juno spacecraft orbiting Jupiter will observe 3I Atlas on March 16, 2026, from 53 million kilometers, 10 times larger than the jet length. However, even remote observation carries tremendous scientific value. Hubble Space Telescope will perform ultraviolet spectroscopy to measure gas composition. Sulfur to oxygen ratios will indicate formation environment. James Webb Space Telescope Infrared spectroscopy in December. JWST will identify every molecular species in the coma. If there are unusual or unexpected compounds, JWST will find them. ESA's JUICE spacecraft will attempt observations in November using cameras, spectrometers, and particle sensors. Data transmission is slow. We won't get results until February 2026. Ground-based observatories worldwide. The International Asteroid Warning Network's Special Observation Campaign began October 27th, dozens of facilities contributing. By December 19th, we'll have complete spectroscopic composition analysis, light curve data showing activity over time, tail structure and dust distribution maps, radio emission profiles, precise non-gravitational acceleration measurements. Either all this data will fit natural comet models, or it won't. Either we'll see a massive tail confirming perihelion mass loss, or we won't. Either the anomalies will resolve into unusual but natural processes, or they'll remain anomalies, days. Then we'll know. Here's the beautiful part of the 3i Atlas story. Science is actually working exactly as it should. We make strange observations. We ask questions. We propose hypotheses. We collect more data. We test hypotheses. And answers start emerging. The resolution of the tailless comet mystery is a perfect example. The tail didn't disappear. We just couldn't see it. Now we can. Mystery solved. Other anomalies, blue color change, rapid brightening, non-gravitational acceleration, high carbon monoxide content, still await explanation. But each new observation puts puzzle pieces in place. As Avi Loeb noted, science offers the privilege of maintaining our childhood curiosity and not pretending to be the adults in the room who know the answers in advance. Whether 3i Atlas is the strangest natural comet ever observed in history, or something that challenges our assumptions about what's possible, it has succeeded in the most important way. It sparked curiosity. Now, as the tail grows longer each day, as the countdown to December 19th continues, the world keeps waiting. Keep watching the skies. Keep demanding transparency. Keep waiting for data, because this interstellar visitor is ready to teach us everything it can about the universe.